جميل. أنا متأسف جدا للdisturbance اللي حصل. لكن as we mentioned yesterday, just to continue from where we started, we stopped. Atoms are the basic units of the elements, and yesterday we said that the simplest representative component of the element, because every element is composed of a unique kind of atoms which are identifiable for that specific atom. And we mentioned the example of the hydrogen atom, as it is unique for the hydrogen because it contains only one proton in the nucleus and one electron in the outer energy shell. This is the routine or the ordinary hydrogen atom. But the hydrogen atom have got two other isotopes. We will see in the subsequent slides the exact composition of the different isotopes of the hydrogen. So the important point here that the atoms are the basic unit of every element, and they are very unique in their composition representing that element. طيب. Modern atomic theory, it says that these are the common rules that will govern the identification of atoms, and how you consider or you imagine the composition of atoms and how they are combined to form the compounds. So atoms are made up of all the matters، أو زي ما قلنا البارح هي المحتويات الأساسية المكون لكل الأشياء الموجودة في الكون، سواء كان يعني جمادات أو كائنات حية أو غيرها من الخلايا وغيرها. Atoms of the same element or one element are different from the other element, as we mentioned in the previous slides, are unique of their structure and their identification of that specific element. And compounds, on the other hand, are a combination of two or more atoms in different proportion, as we mentioned yesterday. And it's very important to remember that the different proportion means that with the same percentage, no matter how much we have of that specific compound. If you have 1 mole of the compound, 10 mole or 100 mole, the proportion or the ratio between the component of the compound will be the same. Okay? The other point is important, the atomic theory, that the chemical reaction involves only either separation of the complex compound form or combining the simplest form of the elements to rearrange the atoms in the form of compound, or rearranging the atoms in different ways. But it does not by any means result in their creation from nothing or destruction. يعني بمعنى آخر التفاعلات الكيميائية بتشتمل إما على فصل مركبات لمكونات الأساسية زي الموية for example، ممكن نفصل إلى الهيدروجين والأكسجين، أو الهيدروجين والهيدروكسيد أيون، أو نجمع وحدات مع بعض نكون منها مركب جديد، أو نعمل إعادة ترتيب لبعض المركبات زي ما في حالة البروتينات والأحماض النووية، يكون في روابط غير الروابط الكيميائية العادية، لكن في نوع من الكيميكال فورسز بتخلي المركبات والمكونات تحت السلاسل البكتيرية في البروتينات، أو السلاسل النيوكليوتيدية في حالة الأحماض الأمينية، الأحماض النووية مرتبطة مع بعضها. لكن أي تفاعل ما بيدي لنا، ما بينتج مركب جديد from nothing، ولا يعمل destroying completely للمكون المركب حتى إذا من مكونات أساسية. وكان هنا قاعد نتكلم عن زي ما هناك قلنا الطاقة لا تفنى ولا تستحدث من عدم، هنا كذلك التفاعلات الكيميائية ما بتعمل لنا إنتاج مركبات جديدة تماما من العدم، ولا تعمل لنا destroying لها، إنما إما ترجع لنا المكونات الأساسية أو تعمل لنا combination جديد عشان تدينا مركب جديد. Okay? So atoms, as we mentioned yesterday, are composed of 3 major components. These are the protons, if you can see the arrow, and on the left side, the electrons and the neutrons. The protons, as you know, are in the nucleus of the atom, are positively charged. They have a positive charge on their nature, and the electrons in the outer energy shell are negatively charged, and the neutrons are neutral. In other words, they just don't possess neither positive nor negative charge. And this is why they are neutral. Also, you know that the protons and the neutrons are both found inside the nucleus of the atom, while the electrons are found rotating outside the nucleus in different energy levels or increasing energy levels, from the first energy level K to the second energy level L, M, N, O, P, and Q, 7 energy levels or seven energy shells, as you may find it in some references, and they are distributed in a different way. We will come through that later, maybe in the other lectures. This is like a representation how the electrons, neutrons, and protons are found in the atom. And as you can see, this black circle represents the nucleus of the atom, and the inside content are the protons for the red color balls, while the neutrons are for the green color ball. And we mentioned that the protons are positively charged, neutrons are negatively charged, and the electrons with the yellow color outside in different energy shells. And this shape, which looks like, to some extent, like the star, is representative of the orbitals or the energy shell around the nucleus of any atom. And every electron or pair of electrons, they have their own energy shell or their own route where they can rotate around the nucleus. The atomic number is represented by the letter Z, as if you remember yesterday in the table. It is actually the number of protons in the nucleus, or we can say for the neutral atom, it is equal to the number of electrons, because for any neutral or normal atom of any element, the number of protons is equal to the number of the electrons outside the nucleus. But usually, because it's more stable and they don't change in their nature, we refer to the atomic number by the number of the protons in the nucleus. واضح يا شباب؟ الرقم الذري هو عدد البروتونات في نواة أي ذرة، وزي ما قلنا كل ذرة عندها عدد بتاع بروتونات يعني يونيك خالص لها، ويقابله عدد من الإلكترونات مساوي له تماما في مستويات الطاقة الخارجية أو في مدارات الطاقة الخارجية. لكن لأنه الإلكترونات عندها قابلية الفقدان أو الاكتساب، الرمز للرقم الذري بعدد الإلكترونات قد أحيانا يعمل بعض الكونفيوجن، باعتبار أنه الذرة قد تكون متعادلة في لحظة معينة تلقى لها تهين الفرصة عشان تفقد الإلكترون أو تدي إلكترون لذرة أخرى، أو تكتسب إلكترون ثاني من ذرة موجودة أخرى. فيبقى كده الرمز للرقم الذري بعدد البروتونات يكون أفضل وأدق في التعبير، ودائما بيرمز على الذرة معينة. أوكي؟ ده نموذج للعناصر المعروفة حتى الآن في الكون، زي ما قلنا أكثر من 100 وشوية عنصر تم ترتيبها في جدول الدوري periodic table، وبتكون في increasing manner of according to the atomic number. زي الفيرست period اللي هي فيها الهيدروجين والهيليوم فقط. The hydrogen have got only one electron on the upper right corner, the number of the electrons, which is the atomic number, or the number of the protons. And for the helium, it has got two protons, and the atomic number for hydrogen is 1, and for the helium is 2. As I mentioned just in the previous slide, The hydrogen is an example which we use it commonly because it's one of our very common examples we have. It has one proton only in the nucleus, and the isotopes of the hydrogen have got one or two neutrons. But the most important now to look at the second row, for example, or the second period: lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. And finally, the neon in the noble gases group, or group number 8. All these are with increasing atomic number. For the lithium is 3, the beryllium 4, the boron 5, carbon 6, and nitrogen 7, oxygen 8, and fluorine 9, and neon 10. The number of atomic number, or the number of protons. And as we mentioned, the number of proton is equivalent to the number of electrons in the outer energy shell for the neutral or the normal element atom. So also, if you look at the vertical groups, group 1, for example, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. The number of the atomic number is increasing manner: 3, 1 in the helium, the hydrogen, 3 for the lithium, 11 for the sodium, 19 for the calcium and potassium, and so on. So this is how the periodic table is arranged, and the message which we want to take from this slide is that all the elements have atomic number which is equivalent to the number of protons in the nucleus, or since they are neutral elements, atom, this will be the same as the atomic the number of electrons. Atomic number is the number of the electrons or the number of protons. The mass number, as we mentioned also yesterday, if you remember, it is the number of neutrons plus the number of protons, or the content of the nucleus. Remember that we said the nucleus of any atom contain protons with the blue and neutrons. So the sum of these two represents the mass number of that specific atom or element. Let's look at these examples. An atom contains 24 neutrons and 25 protons. What is the mass number of this atom? Can anyone interact by solving this problem, preferably without looking at the slides in your own handsets? We mentioned that the mass number equal to the sum of the neutrons plus the number of the protons. Anyone can respond?
Equal 24 plus 25 equal 49.
Okay, so this is the atomic mass of this specific element, and this is how you can calculate it. The mass number equals the number of protons plus the number of neutrons equal to 49. Let's look at this example, number 2. How many neutrons and how many electrons and protons are there in an atom of sulfur with the mass number 33 and atomic number 16? And I need someone else to solve this problem, just to make our lecture more interactive. So we know that the mass number equals the number of protons plus the number of neutrons. Okay? We have it as a given, and we have the atomic number is given. So can we...
So neutrons equal...
Okay.
Equal mass number minus the atomic number. 33 minus 16.
So why did you say minus atomic number?
Because the mass number equals the sum of the neutrons and the atomic number.
And the atomic number is actually the number of protons, okay? That's right?
Yes.
The atomic number equals the number of protons, and the number of protons equals the number of electrons, 16. So the mass number equals the number of protons plus the number of neutrons, and this is 16 neutrons. Okay? So 17 neutrons, sorry, the number of protons and neutrons is 16. So the remaining 33 minus 16, the number of protons or neutrons or electrons, equals 17, which is the number of neutrons. Fine?
Yes, fine.
أي سؤال يا شباب؟ طيب isotopes I mentioned in the first slide, and yesterday I mentioned some clues about the isotopes. They are defined as the atoms of the same element but having different number of neutrons, or atoms of the same atomic structure but differ in the mass number, because the mass number is equivalent to the number of protons plus the number of neutrons. So since the number of neutrons is not stable in the isotopes, the atomic mass of the different isotopes will be different, and these are examples. These are two examples. We mentioned the hydrogen. So normal protein hydrogen has got only one proton in the nucleus without a neutron and one electron in the outer energy shell. Okay? The mass number is equivalent to the number of protons, which is 1, while the second isotope of the electron has got 2 units in the nucleus, 1 proton plus 1 neutron. In the red color, the neutron, and the blue for the proton is still with the same 1 electron. So it is hydrogen 2 or deuterium, and the mass number is 2 because it is equal to the sum of the protons and the neutrons. The hydrogen 3 or tritium is the mass number 3, and it contains 2 neutrons plus 1 proton, and still it has got only 1 electron. So another point to remember and imagine in this diagram, that the size of the electron, if you look at the 3 different examples, is very small compared to the proton. And this is very important to know, that the actual mass of the elements or the atom is condensed in the nucleus, which contains the protons and the neutrons. Although the electrons are very small in their size, but they represent the diameter or the volume which is the element or the atom occupies in the space. So as many electrons as we have and how many energy levels we have, it will determine the diameter of the element atom. For example, in this case, we can imagine this electron, the distance from this electron position now to the center of the nucleus in the proton. This will be the radius of the atom, and it will determine the size of the atom, while the mass is determined by the content of the nucleus. Example number 2 for the carbon. Again, the carbon has got 3 isotopes: carbon 12, carbon 13, and carbon 14. And the 12, 13, and 14 stands for, from what the diagram, does it stand for the atomic number or the atomic mass? When we say the isotope of carbon 12 is the most dominant and represent around 98.9% in the nature, while the other isotope, carbon 13, represent only 1.1, and the very rare isotope of carbon, carbon 14, it is less than 0.0001% in nature. So what does the numbers 12, 13, 14 stands for? Anyone can respond?
Atomic mass?
Okay, the atomic mass, because it is representing the sum of the neutrons and the protons. In the periodic table, the atomic number is usually placed in the upper right side corner. But when you are identifying isotopes, you put the atomic mass on the left upper side corner and the atomic number in the bottom of the element symbol, and this is how it will be represented when you are talking about the isotopes. So carbon 12 means that it has got 2 units in the nucleus, 6 protons and 6 neutrons, while carbon 13 contains 6 protons plus 7 neutrons, and carbon 14 contains 6 protons and 8 neutrons. I have just a quick question. What happens if carbon 13 has 7 neutrons and 6 protons? What will happen if we have carbon 13, for example? Instead of having only 6 protons and 7 neutrons, if we change the number of protons and we assume that it has 7 protons and 6 neutrons.
This will change the atoms. It's be another atom, I think.
Oh, that's good.
Yeah.
That's good. So the number of protons,
carbon,
yes, the protons in the other nucleus determines the nature of the element, whether it's carbon, nitrogen, oxygen, or hydrogen. The atomic number or the content of the protons in the nucleus determine the identity of the element, whether it's of a single nature, atomic nature, or isotopic nature. So if we have 7 protons, it's no more it's not a carbon anymore, it's something else, and we don't want to talk about the details of that. So the number of protons determine the nature of the compound, or the element, and in this case all the atomic number is the same, indicating that the same number of protons. But what differs between the different isotopes of the same element are the number of neutrons. Okay? The molecules, now we are going to form the combination between the elements, either in ionic form or molecular form. If you remember yesterday also we talked about this quickly. The molecule is an aggregate of at least 2 atoms in definite proportion or different arrangement held together by some chemical forces. It may contain atoms of the same element or atoms of 2 or more different elements joined in the same fixed ratio. And these are the examples. Oxygen, O3 now, it is a molecule composed of 3 oxygen atoms combined together by some chemical forces, and in this case covalent bonds, forming the oxygen 3 molecule. But the most dominant molecule of oxygen is O2, the normal oxygen in the air. And the second example is a water molecule, which is composed of oxygen with the blue color and 2 hydrogen atoms. And this diagram also gives you a clue about the atomic size, because the oxygen has got 8 electrons and 8 protons. The electrons are distributed around the nucleus, so they have got more energy shells compared to the hydrogen with the yellow shape, because there's only 1 electron, so it is diameter or the volume is very small compared to the oxygen. When you come to the nitrogen, again you'll see the difference between the nitrogen atom size with the red color and the 3 electrons, or sorry, 3 hydrogen atoms. So again, this is combination of 2 different atoms in a new compound or molecule. This is water molecule, and this is the ammonia molecule. Or sometime in the organic chemistry later you will know that this is known as the amine group, which when it goes to any chemical organic chain, it will be named as the amine group. An ion, on the other hand, is composed, ionic compound of two or more elements where you have some loss and gain of electrons. So this is the brown one, is a neutral atom. If it loses an electron or more, then it will be positively charged and it will be named as a cation of that element. And the ion of any element is different than the original element because it has different chemical nature and different physical properties. If it gains electrons, this atom, neutral atom, if it gains electron, then it would be negatively charged because there are some more electrons than protons in the nucleus. So it will be named as an ion of that specific element. So let's take the example of, if we assume this atom, neutral atom, is for sodium. The sodium, as we know, is metal, and because it belongs to the first periodic group, the vertical group, it has a tendency to lose electron to reach the stable configuration of the noble gases. So by losing an electron, the number of protons in the nucleus will be more than the number of electrons in the outer energy shell, which you previously were equal, 11 electrons and 11 protons. Now the sodium lost one electron and it gave it to the surrounding atoms. It became cation, positively charged, because there is more proton in the nucleus with positive charge compared to the number of electrons in the outer energy shell. It became the cation or the sodium ion. It's no longer sodium atom. Okay? If we assume this is the chlorine atom, because it is in the sixth group, the group 7 vertically, it has a tendency to accept one electron to reach the stable configuration of the noble gases. So it has the affinity to accept electrons. So the electron which is lost by the sodium will be captured by the chlorine atom, and it will become a chloride ion. It's no longer chlorine atom. And why is it negatively charged, an ion? Because the number of electrons now is more than the number of the protons inside the nucleus by having the new electron of the sodium. This is another representation for the sodium ion and the sodium atom. On the left side is the normal neutral sodium atom with 11 protons in the nucleus and 11 electrons in the outer energy shell. So the atomic mass of the sodium is 11, and the atomic number of sodium is 11 because 11 protons, which is equivalent to the number of electrons, the same number of electrons, and the atomic mass of sodium is 23 because it's sum of the content of the nucleus, protons plus neutrons. Because the electron number 11 in the sodium is in the outer energy shell of the sodium and living there lonely, it has a tendency to be lost easily. You can imagine this by the positive power of the 11 protons in the nucleus putting pressure of attraction or pulling into the electrons to the inner side of the atom, and this force will be weakened as we went away from the center of the atom. على حسب الحديث اللي تذكر قلنا النبي صلى الله عليه وسلم قال إنما يأكل الذئب من الغنم القاصية. So this electron is lonely in the outer energy shell, to be easily lost, and this will make the atom of sodium with more positive charge because more number of protons compared to the number of electrons which have been decreased to 10 instead of 11. So this is ion of sodium, and now it became a cation. This is another way to represent the same. The chlorine atom have got 17 protons in the nucleus plus 17 electrons, and the neutrons are, the number of protons is 17, and the number of electrons is 17 as well. So this is the mass, the atomic number of the chlorine, and one of these the 7 electrons are in the outer energy shell, but they have the tendency to accept one more electron to become 8 electrons and will have the stable configuration of the octet rule. So they will attract an electron from the sodium, and it will become more electrons by one more electron. So the number of electrons will be more compared to the protons, and that's why it's negatively charged. The overall charge is -1, so it is an anion and negatively charged. If we make contact between these two, or we bring these two ions, the sodium ion with positive charge and the chlorine ion which is negatively charged, they will make a new compound which is known as the ionic compound of sodium chloride. واضح يا شباب؟
واضح.
So the common
Yes,
ions,
واضح.
the common ions are, as you know, are divided either into positive ions, the cations, or negative ions, the anions. Okay, the cations are the hydrogen, the lithium, sodium, potassium, cesium, beryllium, magnesium, calcium, barium, aluminum, silver, and zinc. These are just examples, not all the cations. Whenever any one of these loses one electron or more, like the case of the calcium or magnesium or beryllium, they will be positively charged, as will be cations, while the others, they can accept electrons. Even the hydrogen can play both the cationic nature and anionic nature by accepting an electron, and in this case the name will be hydride. And for the fluorine which accepts electron will be fluoride instead of fluorine. Chlorine will be chloride, bromine will be bromide, iodine will be iodide, oxygen will be oxide, and sulfur will be sulfide. So it's very important to know that the anions usually in the chemistry, their nature or the name will be changed by adding the suffix IDE instead of the normal suffix of the element, the neutral element. Hydrogen is a normal hydrogen in neutral, or a form, the cationic form. When it accepts an electron, it will be named as hydride. Fluorine will be named as fluoride, so we change the suffix of the name of the compound, the element, by changing IDE, which stands for the anion form, or the element which has accepted electron or more, as in this case. These are known as the single ionic compound elements, or singular ionic cations or anions. You can find poly atomic ions like the hydroxide, the amide, the nitride, the phosphate, and so on. This will be later in other lectures. Okay?
Teacher, I have a question.
Okay, welcome.
Why hydrogen atom, when we accept one electron, we say it is hydrogen anion? Why we can't say that hydrogen can be helium?
Okay, in this case, the hydrogen, because it accepts the electron, is no longer the normal neutral hydrogen. That's number one. Number two, it will behave like the non-metals. And in chemistry, all the non-metals, when they accept the electrons, their name will be changed by the suffix IDE instead of the normal hydrogen or chlorine or fluorine, as we mentioned. It will not be helium, because the helium have got 2 protons. It is an ion of hydrogen with 2 electrons and 1 proton still. You got it? The nature of the element, the original nature of the element, which contain only 1 proton in the nucleus, has not been changed. Only it either loses electron or accepts electron. It became an ion. Can be a positive ion, behaving like metals, or negative ion, behaving like the nonmetals. Since it behaves like the nonmetals by accepting an electron, then it will be hydride instead of hydrogen. But the positive ions will sustain their original names without having any change, but you change you add the positive charge on the symbol of the atom, indicating the ionic nature. Okay.
Okay, I get it.
Okay, so the chemical formula, whenever we have a combination of elements in the form of compound, whether ionic or molecular compound, we have different ways of expressing this combination. And to express this composition or combination of the atoms in the ionic or molecular way, we have two ways, either the empirical formula or the normal chemical formula. So, as you remember, elements in the same ratio will form new compounds. They can be ionic compounds or molecular compounds. These are examples. The chemical formula for the C6H12O6, if you remember yesterday, we gave this example. This is a glucose. The molecular formula for the glucose is the exact number of atoms of each element of the component of the molecule. So this is the molecular formula. The empirical formula, it is like the basic proportions of the content of the compound. So when we are talking about the difference, it will be more easier to have this example. The molecular formula for this butane is C4H10, but this is the molecular formula, the exact way how many atoms and of each of the component represents the butane molecule, or butane, yes, butane molecule, which is one of the aliphatic hydrocarbons. But the empirical formula gives the basic proportion or the elementary proportion of the atoms. That means the ratio carbon to hydrogen by 2 to 5 is the empirical formula. If you look at the octane, which contain 8 carbon atoms and 18 hydrogen atoms, the empirical formula, which is the basic formula from which represents the octane, will be C4 and H9. واضح يا شباب؟ الصيغة الجزيئية والصيغة الأساسية. إذا صح التعبير في الامبيريكال فورمولا يقول عليها الصيغة الأساسية والصيغة الرياضية لنسب توزيع الذرات في البيوتين 2 إلى 5 كربون وهيدروجين و4 إلى 9 كربون وهيدروجين في حالة الأوكتين أو البيوتين 2 إلى 5. والصيغة دي بتكون صيغة أساسية ثابتة. أوكي. النيمينج اوف كومباوندز بعد ما حصل لنا يعني combination للاليمنتس في شكل compounds whether in the ionic way زي ما ذكرنا امبارح ممكن العناصر تتحد مع بعض عشان تدينا مركبات اما بفقدان الكترونات واكتسابها في حالة تدينا مركبات ايونية او بالروابط التساهمية في حالة تدينا مركبات تساهمية او covalently bonded compounds. Also, the compounds can be named according to their tendency of ionizing in the water molecule and the water aqueous media and dissociate to give hydrogen ions or to accept hydrogen ions, and in this case they will be named or classified as acids or bases. So we have got 4 different ways to express the nature or the naming of the compounds, either according to their سوري يا شباب، قالوا انه الواي فاي بتاعي قطع النهاية، متاسف للقطعة دي. يعني كنا نتكلم عن الباينري كومباوندز، المركبات الثنائية مكون من ايونات. تاني شايفين السلايد يا شباب؟ الو؟
بس كان على
أيوة.
هنا كان في compound ions.
هسه ما ظهر عندكم؟
لا، كنا في النقطة القبلية اللي هي first types for naming the compounds.
يا أخي
or
يعني طلعت الشبكة قبل ما حسي؟ طيب الآن الجدول ده ظاهر؟
yes,
ايوه ظاهر.
but we are
طيب
in the previous point.
قبل كنا بنقول إنه النيمينج أوف كومباوندز بتسمى مركبات على حسب تكوينها، إما من مركبات من جزيئات أيونية زي ما ذكرنا في حالة الصوديوم كلورايد فور إكزامبل. يعني الوحدات الأساسية لمركب هي أيونات موجبة أو سالبة على حسب الفقدان الإلكترونات أو اكتسابها، أو مركبات تكون مكونة بالشيرنج أوف إلكترونز، والحالة تكون مركبات أيونات تساهمية أو موليكيولر كومباوندز. وممكن نسمي المركبات بصورة كيميائية على حسب القابلية بتاعت اكتسابها للهيدروجين أو فقدان الهيدروجين. إذا كان عندها قابلية تتأين وتدينا أيون هيدروجين بنسميها أسيدز أو أحماض، أو عندها قابلية لأنها تتأين وتدينا أيونات تكسب الأيون الهيدروجين بنسميها بيزز أو الكالاينز. وحناخد من أمثلة في السلايدات الجاية. واضح؟ يعني تسمية المركبات بعد ما حصل كومبينيشن لعنصرين أو أكثر، سواء كان من نفس العنصر يعني تكرر منه وحدتين اتحدوا مع بعض ادتهم يعني جزيء جديد، أو جاتنا أيونات موجبة وسالبة اتحدوا مع بعض ادت مركب جديد. نسمي المركبات على حسب الطبيعة الغالبة فيها، هل هي مركبات أيونية أو مركبات تساهمية أو مركبات عندها قابلية للتأين ويعني يعني التبرع أو فقدان الهيدروجين، أو عندها قابلية لاكتساب أيونات الهيدروجين تكون أحماض أو قواعد. الأمثلة دي في الجدول الموجود هنا. الأيونيك كومباوندز المركبات مكون من رابطة أيونية فيها فقدان واكتساب بتاع إلكترونات. ممكن تكون ثنائية العناصر باينري كومباوندز، أو تيرنري كومباوندز وتيرشري كومباوندز على حسب عدد الإلكترونات المكونة فيها والذرات. المثال الأول الصوديوم كلورايد، زي ما عارفين دي الفورميلا بتاعته، في يكون أيون بتاع الصوديوم فقد إلكترون، وفي أيون بتاع كلورين أو ذرة كلورين اكتسبت الإلكترون بقت أيون بتاع كلورايد. الاسم بتاع المركب يكون صوديوم، الميتال ياخذ نفس اسمه بدون ما يتغير، والنون ميتال يكون هو الجزء الثاني من اسم المركب، ويتحول النهاية بتاعته سافكس بدل ما كانت كلورين إلى كلورايد زي ما ذكرنا في الجدول السابق على الأيونات السالبة. دائما يتغير نهايتها إلى IDE indicating that it is an anion. So the combination of sodium and chlorine by losing or accepting electrons, it will give us the ionic compound which is known as sodium chloride. Another example is potassium bromide. It was previously potassium atom neutral and bromine atom neutral. The potassium loses an electron and the bromine accepts the electron, so it became bromide ion, while the potassium remains as and it sustains its name as potassium. So this is potassium bromide, the way of naming. The zinc iodide, because of what one zinc can lose 2 electrons, and each of the 2 iodine atoms can accept each 1 electron, so it will be iodide ion, and the zinc will sustain its name. It will be zinc iodide, while only 1 zinc atom and 2 iodine ions. So it is 1 to 2. This is the ratio or the definite proportion, if you remember. And the same for the binary molecule of the aluminum oxide. 2 elements of aluminum, each will lose 2 electrons, and 3 atoms of oxygen, each will accept the 2 electrons. So the number the 3 electrons of each of the aluminum are accepted by the 3 atoms of the oxygen, so this aluminum oxide. The ternary or the tertiary compounds, or which is of ionic nature, like the lithium hydroxide or the potassium cyanide. Okay, so 3 atoms share the same compound, but by ionic bond. So in this case, the hydrogen and oxygen, they form the hydroxide ion together, and this, the carbon and the nitrogen form the cyanide ion, and the lithium represents the positive ion, while the hydroxide, both together the polyatomic anion, have the negative charge. So the attraction between these two give us the lithium hydroxide. أيوة نعم نعم يا بنتي سؤال. طيب إذا ما نواصل. طيب المولكيولر كومباوندز في المقابل للمركبات الأيونية، المركبات التساهمية اللي هي مكونة من روابط فيها sharing of electrons. نعم في سؤال ولا ده حديث خارجي؟ طيب again المولكيولر كومباوندز ممكن تكون ممكن تكون باينري أو ممكن تكون مالتيبل، على حسب عدد الذرات المكونة للمركب. ده مثال للباينري فيها مركبين فقط. هنا عندنا الكربون والأكسجين بيتحدوا 1 كربون مع 2 أكسجين، كل أكسجين عنده زي ما عارفين إلكترونين محتاج إنه يكمل عشان يصل للثبات الثماني، والكربون عنده نقص 4 إلكترونات، سو بيتعاون مع الأكسجينات الاثنين بانه يديهم يعني شيرنج الكترونين مع كل واحد اكسجين، ده يصل للثبات الثماني، والاكسجينات كذلك كل واحد منهم ياخذ الكترونين بدون ما يكون في كومبليت ترانسفير من الاوتر انرجي شيل بتاع الكربون او الاكسجين للاذر، بس جست شيرنج بدون مركب تساهمي من اللي هو الكربون دايوكسيد في الحاله دي، او الهيدروكلورايد او الهيدروكلوريك اسيد والكربون مونوكسيد. So دي مركبات تساهمية molecular compounds. النيتش بتاعت المكونات حصر وحدات فيها عبارة عن molecules. one molecule of carbon dioxide يعني 1 جزيء من الكربون والأكسجين متحدات مع بعض بنسبة 1 إلى 2. الهيدروكلوريك أسيد والهيدروكلورايد اللي هو HCl عندنا 1 هيدروجين 1 كلورين 1 to 1، والكربون مونوكسيد 1 to 1، لكن ما في complete transfer of electrons. دي تسمى بنفس الصورة بتاعت الهيدروجين كلورايد او الكربون دايوكسيد او الكربون مونوكسيد. اوكي again العنصر الاول على اليسار يعتبر كانه ميتال، والعنصر في اليمين اللي هو ما في فقدان ولا اكتساب بتاع الكترونات زي ما ذكرنا بياخذ الصفه بتاعت النون ميتالز، بيكون اسمه النهائي يتغير من النورمال أكسجين أو الكلورين أو الأكسجين إلى الأكسيد. So it will be carbon dioxide, hydrogen كلورايد أو كربون مونوكسيد. في حالة الأسيد والبيزيس البروتون دونرز هو بتاعت عندها قابلية في الأوساط المائية تتأين تدينا إما أيون هيدروجين أو تكسب أيون هيدروجين. إذا كانت تدي أيون هيدروجين زي ما في حالة هيدروكلوريك أسيد HCl عنده قابلية في الأوساط المائية يتأين إلى أيونات هيدروجين موجبة وأيونات كلورايد سالبة. So once it can give the hydrogen ion, it will be named as an acid, and this is hydrochloric acid. وهيدروكلوريك لو ملاحظين تكون من الجزء الأول بتاع الهيدروجين والكلورايد أو الكلورايد ايون، لكن لأن عندها طبيعة إنها تفقد الهيدروجين تتحول يسوى من هيدروكلورايد إلى هيدروكلوريك أسيد. أوكي لأننا بنسميها أسيك أسيد. هنا الكربونيك أسيد برضه H2CO3 عنده قابلية يتحلل أو يتأين يدينا أيون هيدروجين. So since it can give the hydrogen ion or can donate the hydrogen ion of the proton, it will be named as an acid. So it will be carbonic acid. Even the bicarbonate in this case can again ionize in the water aqueous media to give the carbon carbonate, molecule, and the hydrogen ion. Again, it can act as an acid or it can act as a base, because it can again accept this hydrogen and become hydrochloric, the carbonic acid ion, or the carbonic acid. And bases, substances that accept the hydrogen ion, like this case the bicarbonate ذكرته قبل شويه، عنده قابليه طول ما عنده شحنه سالبه هنا وفي ايون هيدروجين موجب ممكن يحصل تراكشن بيناتهم ويدونا كربونيك اسيد مره اخرى. بالتالي البايكربونات لان عندها قابليه تكسب البروتون او الايون بتاع الهيدروجين بتسمى بالبيز واسمها يسمى بالبايكربونات. والفوسفات جروب هنا عنده 2 نيجاتيف تشارج وهنا في ايون هيدروجين موجب، فبالتالي عنده قابليه يكسب الايون الهيدروجين عشان يعادل الشحنه دي يدينا باي فوسفات موليكيول، وبالتالي حيكون هو عباره عن بيز لانه accepts the proton ويسمى بالفوسفات، واللي بيختلف عن الكربونيك والهيدروكلوريك اسيد زي ما ذكرنا قبل. اخر حاجه الميكشرز في المحاضره العمليه، لو تذكروا قلنا امبارح الميكشرز هي combination of 2 or more elements or 2 or more compounds, and usually we have solvent and solute على حسب النوع بتاعها تكون المركبات. These are elements, the oxygen element in the red, the nitrogen element in the blue. These can combine in the same container, for example, to form a mixture of oxygen and nitrogen. Both are nonmetals. They can combine in the same medium, but without complete miscibility in this case. Also, the carbon dioxide is a molecule. هنا كنا نتكلم عن elements، element واحد أكسجين، element واحد نيتروجين، وهنا نتكلم عن compounds اللي هي الكربون دايوكسيد أو الموتر molecule. They can mix together, forming a new mixture between the carbon dioxide and water. And as you know, mixtures can be either homogeneous mixture where they have some common forces between their components and their particles, or they can be heterogeneous mixtures. Like the example, sand and water can mix with each other, forming a heterogeneous mixture. In other words, it's unmixable. You can rotate or you can stir the sand with water. For some seconds, it can give you like it is coming to become like a homogeneous solution, but quickly it will precipitate to the bottom of the container, giving complete different layers. The water will be on the top and the sand will precipitate on the bottom. If you compare this mixture with the sugar and water, you will find that the sugar can dissolve completely in the water, forming homogeneous mixture. So to this level, the mixtures are different from the compounds. If you remember yesterday, we said the components of the mixtures not necessary to be in the same ratio or the same proportion. You can put 10 moles of sand, or let's say about the homogeneous mixture in this case of sugar and water. This is homogeneous mixture of sugar and water, okay? Because it's completely different and very obvious, not miscible with each other, let's talk about this miscible combination. The sugar in water will form the homogeneous mixture of water and sugar, regardless of the amount or the ratio of the molecules. You can have 10 moles of sugar, glucose, in 100 liters of water or 1 liter of water. Still, it's the same mixture of sugar in water. If you add only 1 mole of sugar to 100 moles of water, still you are talking about the same mixture, homogeneous between the sugar and water. The other property of the mixture is that they can be separated by physical means, not necessarily by chemical means. But the compounds, apart from being with different proportion, you cannot separate the combination of the compounds without a chemical reaction. Also forming the combination of the chemical reaction, the chemical compound need a chemical reaction to form the new compound which combining the two components or the more components. واضح يا شباب؟
Yes, clear.
Okay, I give this very simple example of the mixtures because in the future we have got a separate lecture about the solutions and how they have different ways to express their concentration and how you can have a true solution, colloid solution, whatever was the different mixtures of the normal homogeneous solutions. The heterogeneous mixtures usually in the biological system and the normal living cells, we don't have it so much. We can have some areas where it's important because like when the skin have some barriers of absorbing any water by having some fatty content in the surface of the skin, we are forming like an insulator. This will be of very important at that specific point. But otherwise, usually in the living system and the cells and the human body, we deal mainly with homogeneous mixture or solutions, and this will have a separate lecture. Any question?
Teacher.
Okay.
Teacher.
نعم
In
نعم.
the example of water. In the example of water plus sugar.
And sugar, okay.
It will be just the concentration will be changed, be more
Yes.
light, but it is the same ratio, right?
No, not the same ratio. The same components. But the concentration will be different, but having the same component, but it's not a compound because the ratio is not the same. You can have 1 liter of water, and you can dissolve 1 gram of sugar, 10 grams, 20 grams, even 100 grams, 100 moles of sugar. It still is known as the mixture of sugar in water. But if you add 1 molecule of sugar, so if you have sodium, and 2 molecules of chlorine, they will not give a new compound. They will give you only 1 salt, 1 sodium chloride atom, and the excessive chloride ion will not have any sodium, so it will not be combined to the original combination of the sodium and chloride. واضح يا بنتي؟ يعني زي ما قلنا قارنا الشوجر مع الووتر هنا كميكشر مع الصوديوم كلورايد. قلنا إذا عندنا هناك مول واحد من الصوديوم فقد إلكترون أو عدد إلكترونات بعدد المولات، وعندنا 2 or 3 moles من الكلورايد، فقط مول واحد منها حيكسب الإلكترونات دي ويعمل الصوديوم كلورايد 1 to 1. الزايد من الكلورين موليكيولز أو المولز ما حتكون عندها فرصة تتحد مع الصوديوم لأنه خلاص ما في صوديوم يكفيها. لكن في حالة الميكشرز لأنه ما في typical يعني chemical bonds يعني يقولوا covalent bond بيناتها ولا ionic bond، بالتالي ما حيكون في يعني combination في أو ما حيكون في مشكلة في إنه يتحدوا مع بعض ويعملوا نغم بيحصل saturation. فدي حاجة تانية في السوليوشن هناخدها بتفصيلها. أوكي؟
Okay, nice.
أوكي، بقى سؤال تاني؟ The summary: atoms are the basic units of the elements, as we mentioned, and the symbols represented parts. The atomic number is the number of protons in the nucleus, and it is almost equal to the number of electrons. The mass number A equals the number of protons plus the number of neutrons. The atoms of the same element or atomic have the atomic same number and different mass number. They are called isotopes. And isotopes are usually they have some sort of radioactivity، ودي حاجة إشو مختلف خاص هنتكلم عنه إذا سمحت الفرصة في وقت لاحق. أي سؤال ثاني؟ So if no question, thank you for your presence and for your interaction with the lecture and your response. I hope the lecture is useful and fruitful. You can stop the recording here.